Alright, today I'm going to be talking about elementary series and alternating series. As you can see, I was trying to tell the B2C students that these are very, very important. If you do not memorize these four series, you will not do well on the series questions on the test. For instance, one of the BC review questions that I gave out for just the spring break, it's like find the coefficient of sine of x squared. Find the coefficient of x to the sixth in the Taylor expansion for sine of x squared. That's almost an impossible task if you need to do the derivative. It's a question designed to test if you have memorized these four series. So most of these series I've covered before. Actually, all of them I have in other videos. All of these series come up these are particularly mentioned in 7-5, sine of x and cosine of x. E to the x we touch on in 7-4, as well as natural log of x. And by touch on, I mean we derive these series. Or I guess we derived this one in 7-5, but we talked about it in 7-4. Ouch. Now, this series, natural log, is the only one with a specific interval of convergence. These three converge for all numbers. Okay, we talked about interval of convergence back in 7-3. So these ones all have an interval of convergence. All real numbers. Or this is the notation you'll be asked to use most of the time. And they're centered at x equals 0. Right? Nothing's being subtracted. If you need to review lesson 7-5, please do so. A lot of this stuff won't make sense centered at what. Natural log is the oddball here. Natural log has an interval of convergence only between 0 and 2, which is again at less than 2 and bigger than 0 strictly. And it's centered at, can you tell? X equals 1. That's why there's a minus sign, -1 in each of the, what would you call them? Powers, I guess, yeah. Okay? So, natural log is the one that's going to be hard to remember. All of these have factorials. Natural log has no factorial. Natural log does have it matching. The exponents match the denominator. That sometimes makes natural log easier to pick out. Some of the questions you'll see on your homework will be like, which elementary series is this? And they'll just give you some random sigma notation. If you do not see a factorial, it's natural log. Pretty much guaranteed. Not always, like there's ones that aren't, but you have to see the structure, but you don't see factorial. If these are factorial, I would imagine it's one of these three. Okay, and so this is just something you memorize. And there's no ifs, ands, or buts about it. We talked about in lesson 7-5, sine is an odd function. 1, 3, 5, 7 are the odd powers. Sine of 0 is 0. And wouldn't you know it, if I plugged in 0 to all of these x's here, I would also get 0. Cosine of x is an even function. 0 power, 2, 4, 6, all even powers. And cosine of 0, if I plug in 0, for cosine I get 0. And if I replace all these x's with zeros, I get 1. You can check that with e2, e to the 0 is 1, and all these guys go to 0. Okay, these are just nice. E to the x is the best one, in my opinion. 1, x squared over 2, x cubed over 3, factorial, right? Very nice series. So the way you'll be asked to work with these is usually, hey, you You know what sine is. Now give me a series for sine of x squared. Literally on multiple choice. I just gave out for spring break. So if that's sine of x, what's sine of x squared? So I'm just going to take all of these x's and replace it with x squared. I'm going to take all those x's and replace it with x squared. So it'll help you a bit if I write it down, I think. So here's sine of x. You know what I'm going to do? I'm going to be smart about this. I'm just thinking, oh man, I feel lazy. I don't want to write all that. Well, it should be locked. Okay, so for sine of x, I'm talking about this one. Right? I'm talking about that series right there. So if I took x, and everywhere I saw x, I replaced it with x squared, that's going to become x squared. That's going to become x squared cubed for 3 factorial. That's going to be x to the 5th. Nope, sorry. X squared to the 5th over 5 factorial. Minus x squared to the 7th. The standard AP test uses almost always 4 non-zero terms and ... the general term. So 1 to the n x squared to the 2n plus 1 over 2n plus 1 factorial. Plus ... As I mentioned in 7-5, without this ... and this ... your answer will almost always lose a point. They're necessary for equality to hold. Otherwise, it would be an approximation, especially this ... at the end. Look at all of them. They all have both sets of ellipses. These are called ellipses or ... Okay, so there you go with sine. There you go with sine. Cosine of x. Oop. So again, now I'm going to be looking at replacing all of the x's with root x. Root x replaced x over here. I'm not taking the square root of every term. That's what some students think. I'm not taking the square root of the whole thing. I'm replacing the x here with root x. Every x I see gets replaced with root x. So here I go. 1 minus root x quantity squared over 2 factorial. Yes, you can simplify that. You do not need to get a good score. Root x to the 4th over 4 factorial. Plus, minus, root x to the 6th over 6 factorial. The exponent and the factorial are still matching. It's so nice. It's not that hard to remember. Plus, ... negative 1 to the n. Don't ever forget that. That's what makes it alternate, which is going to be a big part of this lecture. Spoiler. To the 2n power all over 2n factorial. And again, it's fine if you want to simplify, but it's totally not necessary. X squared, x to the 3rd. Okay? In fact, it sometimes makes it a little less clear, the connection between the factorial and the exponent. Okay? So that's how we use cosine. Let's do one with good old-fashioned e to the x. Okay, so if e to the x equals this, if e to the x equals this series, then Well, I can just do this kind of a thing. Oh man, I'm so sorry. So x times e to the x can be written x times all of that, right? I replace e to the x with its series, and I get really happy. Because now all I have to do is distribute infinitely many times, but that's easy. X plus x squared plus x cubed over 2 factorial. See, I see the connection between the power and the exponent, the power and the factorial so much that I do it even when it's wrong. X to the 4th over 3 factorial plus dot dot dot. Now what's x times x to the n? And a lot of BC students struggle with something as simple as this: x to the n plus 1 over n factorial plus dot dot dot. You have to be really good with your exponent skills, or else things will just be terrible. Okay? But that's the series they want. That's it. So this is a nice review of 7-3 as well. Oh no, 7-4. Okay, this lesson is the crowning achievement of Chapter 7. If you understand this lesson, great. You need to. Okay, 1 over x. Now how am I supposed to make a series for 1 over x? We learned techniques to do this in 7-4. In 7-4, we talked about rewriting 1 over x as 1 over 1 minus r and making a geometric series. But now I don't need to do that. Because I've memorized certain things, I won't need to do that. So do you see a connection between 1 over x and one of the 4 elementary series? Oh, you do? You see a connection between this 1 over x and, oh no, and natural log? Sorry. Yeah, you do, because there is a connection there. So I'm going to have it highlighted at the bottom. Okay, so the idea is it's the derivative of natural log. So how do I get that? I want to take the derivative of each of these terms. Now how does that work? What's the derivative of x minus 1? You can think about it, but it's 1. The derivative of x is 1, derivative of negative 1 is 0. Now a lot of students struggle at the derivative of the next thing. I would bring the power down, decrease the power by 1, and keep the bottom the same because the denominators are all constant. Now you might notice that these will cancel. That's okay. I don't need to worry about that. Bring the power down, decrease the power by 1, keep the bottom the same. Bring the power down, decrease the power by 1, bottom stays the same. Plus, dot dot dot. Oh, I missed a plus here. Oh, did I? Yeah, no, there definitely should be a plus. Sorry, go back. If you wrote all these down, which you should write them down a million bajillion times, you need that plus. Mucho importante. Muy, I know it's. Don't worry about me. Negative 1 to the n plus 1. Now, a lot of my students struggle with doing calculus, which is almost always the power rule for series, when it looks like this. This is a constant. We are not taking the derivative with respect to n. Does this have x in it? No. Does this have x in it? No. This does. So I'm doing the power rule to it. Like that. And the bottom stays the same. And yeah, again, if you notice, all of these will cancel quite nicely. And you could simplify this series a great deal. Okay, next. Now I want to integrate this term by term. Now maybe you were worried the whole time. Why isn't Mr. Leven multiplying by the derivative of the inside? The derivative of the inside of each of these is 1. Because the derivative of x minus 1 is 1. So I would be multiplying by 1, by 1, by 1. Now that's going to help us when I go to integrate this term by term. When I go to integrate this term by term, it's the same thing. If I'm integrating this, I can just integrate that guy and integrate that guy and whatever. But I don't want to. I want to do it smoother. So I'm going to say that the antiderivative of this is x minus 1 squared over 2. Because I see a power, I see its hook off, 1 right here. So I can just add 1 to the power, divide by the new power. Same with here. I can add 1 to the power and divide by the new power. Now I'm going to write it in order. Just because that's how I think about it. 2 times 3 is fine. I'm going to add 1 to the power. And you can get really sloppy with that if you aren't understanding. Like, you could think this is how you always should do the reverse power rule, that the hookups don't matter. The hookups matter a lot. Please be sure you have them. But I know I have the hookup now because it's 1, 1, 1, 1. All the time 1. Add 1 to the power and divide by that new power. Dot, dot, dot. And again, I know students struggle with this. This is constant. This is constant because x is the thing I'm interested in. So the antiderivative doesn't change it. It just does not. So I add 1 to the power, and I divide by the new power with parentheses around it. Make sure you have those parentheses. It means something else if you don't. One thing you can always do is check that this formula is working over here. When I plug in 0, do I get the right thing? Not 0, sorry. This one's starting off with 1. When I plug in 1, do I get the right thing? Negative 1 squared, so it's positive. 1, 1 to the 0 power. Anything to the 0 power is 1. Checks out. When n is 2, 2, 2. Negative 1 to the 3rd power is negative. 2 minus 1 is power of 1. Okay? These formulas should work all the way down the line. And that's all I have to say about using the elementary series. It's just memorizing it. Please try out all the exercises. It's really not that bad. This is a good section. Alternating series is a series whose terms alternate between positive and negative. I think I've been mentioning alternating series for a long time now. So basically we have plus term, a minus term, a plus term, a minus term, or minus, plus, minus, plus. Okay? Now, these are the same. They're both alternating. What's not alternating? Okay, these are alternating. You would see one of those two patterns. What's not alternating? Plus, plus, minus, minus, plus, plus, minus, minus. That's alternating in a certain sense, but that's not what we're talking about when we're talking about alternating series. Okay? It needs to be alternating in this sense. Okay? 3 of the 4 elementary series are alternating. Now I feel a little bit like a middle school, elementary school. Which one of these are alternating? You should have said cosine, sine, and natural log. See how it goes positive, negative, positive, negative? Same, same. Always positive, not alternating. So, these come up a lot. This is the last test you're expected to learn in the unit. I'll go over all the tests that the unit used at the end. But this is a test for convergence. It does not show divergence. It can never show divergence. So we have a positive part. The alternating series is this one or this one. This is one that's starting off on a negative foot. This one's starting off on a positive foot. That's all it's saying with the different exponent. And that this part's always positive is important, so it does go in this fashion. That's what an alternating series means. If it were not always positive, then you would have some weird stuff going on. So again, don't just look for the negative 1 to the n or the negative 1 to the n plus 1. Look for an actual alternating series. Actually write out 4 terms. Make sure it's alternating. Okay? So, we can show convergence if we show 2 things. Thing number 1, that the terms never increase in absolute value. So this term some students find troubling, never increase. What does that mean? Really, it means non-increasing which is stronger, which is it's a weaker statement than, so decreasing is okay. It just can never go up in absolute value. Okay? It can never just start increasing. It can go 1, 1, 1, 1, 0. It can't go 1, 2, 1, 0. Alright, we talked about this in lesson 7.2. 1, 1, 1, 1, 0. That's an example of non-increasing. 1, 0, negative 1. Oh, I'll do it differently. 5, 4, 3, 2, 1. That's what we would call a decreasing sequence. And obviously 1, 2, 1, 0. Neither. Okay, just so we can see what we're talking about. I should have commas. Sorry. Blah, blah, blah. Okay, so either of these are okay. Not this. Not going up or down. Okay? That's what never increasing, that's what we're talking about. This is just to make sure NTT works. Okay? So the NT team passes. Make sure it passes the nth term test. The nth term test, remember, said that a series will fail, so it will not converge if the limit's not 0. Okay, a series will diverge if the limit's not 0. It said if we equal 0, we don't know anything. Okay? So limit absolute value equals 0 is another way of thinking about this. Okay? Okay, the limit of the absolute value of the series. That's what we want. We need both of these things. I'll go about nth term test later. If this were not 0, it would diverge by the nth term test. That's what we're saying. Here I go. I'll show you what I'm talking about. So I see this guy, and I would see two things. First, let's write out a few terms. Let's write out a few terms of this series. So at 1, this would be squared, so it's positive. Then 2 cubed, so it would be negative 1/2. 3 to the 4th, so it would be positive, negative, and then so on and so forth. Now, I look at this, and I want to think about two things. First, I want to think about what's the limit. So it's something along the lines of this. I'm thinking about limit as n goes to infinity, absolute value which is the same as this. Because that -1 inside of absolute value is doing nothing. Frequently, we'll just start writing this because we'll know it's an alternating series and we know we can just chop off the alternator. Okay, now what's this limit? If you said without 0, you are right. So that's one thing. That's the first check. Second, part 2. Let's think about the terms. So the absolute value of the terms. And I'm not going to write this out ever again, but the absolute value of terms would be like 1, 1/2, 1/3, 1/4. If we ignore the signs, always decreasing. And then you would say something like, so. Sorry, you should have labeled this as step 1. I don't know why I labeled it. It's bothering me. So, this series converges by AST. Okay? That's how it goes. I check out the absolute value of this. I check out the absolute value of the terms. We want this to be decreasing or at least non-increasing. The reason is, okay, if you look at this, 1 is bigger than -1/2, but -1/2 is smaller than 1/3. So the terms themselves are not decreasing. The terms themselves are not decreasing. The absolute value of the terms is always decreasing. Okay? Now, this other one. What does this series look like to us? Let's write out our first few terms. So for n equals 1, we get positive 2 over 1. N equals 2, we get negative 3 over 2. For n equals 3, we get positive 4 over 3. Negative 5 over 4. Plus ... Okay? Let's think about this. The first thing I want to do is check, is it alternating? Oh, it's definitely alternating. Great, so I can use the alternating series test. So my first check is limit, and then throw off the alternating part. That's what's okay, that's what I'm saying. I can write that if you want to, but that's all that absolute value is doing, is getting rid of that. Now what's this limit? It's 1. You should still know it's 1 from, I don't know, the very first units of the class. That limit's 1, which is not 0. So the series diverges by the nth term test. Not by the absolute series test? Alternating series test. Absolute, sorry. Alternating series test. Okay, that's the statement you want to write. And usually, if it fails the alternating series test, it's because of this. So don't worry about the other case. Now, in case you forgot everything, we ended this lecture by talking about all the tests covered in Unit 7. There are only 3 of them, which is the good times. Because by the end of Unit 8, you will have 7 series tests. As you might know, you need to have memorized all of them. So start working on that now. Build up a study habit. So here you go. We have the nth term test for divergence. If the limit's not 0, then the series diverges. It's inconclusive if the limit is 0. Okay? It's just inconclusive. Does not show a convergence. You never say it converges by the nth term test. The geometric series test is the only one that shows divergence if it's bigger than 1, and convergence if it's less than 1, if the absolute value of r is less than 1. And this is what they look like. Again, it's some number to the nth power. Some number to the nth power. And then the one we just went over, okay. Check, check, check. Make sure you work on assignment 7.6. Make sure you work on assignment 7.6. Watching this video alone will not be enough to pass the AP test. I can pretty much guarantee it. Full stop. I appreciate all your hard work. Thank you for taking the time to watch these videos. Let me know if you have any questions by email or in person, and I'll talk to you soon. Good luck with your studies. Have a nice day.